Careful.
Hey everybody, I'm Ed from Off-Chain Labs, and I want to talk to you about Arbitrum Stylus. And I'd like you to remember two things when I'm done. First, that Arbitrum Stylus is a big step forward for Web3 development. And second, that Arbitrum Stylus went live on the Arbitrum 1 mainnet today, about 13 hours ago. Okay, now until today, if you're a Web3 developer, you have to make a bunch of decisions, but one of the key decisions is to use the EVM, Ethereum Virtual Machine, or not. EVM has a lot of advantages. I'll talk about some of them. One of those advantages is that it has the largest base of users and liquidity and a large developer base in the Web3 world. But by the standards of the whole world, this is a relatively small developer community and a relatively small software environment. For every EVM developer on the planet, there are about 100 Rust developers and about 400 C, C++ developers. So if we want to expand our technology to the next billion users, we have to start by bringing on board the next million developers. And the EVM ecosystem is far from that. So the EVM, of course, has a lot of virtues, as I said. It's meant to be small. It's meant to be easy to price, meaning that it's relatively easy and safe to do things like gas tracking and resource management in EVM. And that's no small feat. It's one of the reasons why EVM has been very successful. The code written by devs translates into EVM bytecode, and it runs that way. But most developers, of course, although EVM in principle could be used with different programming language, most developers use Solidity, some use Viper, but EVM has not been hooked up to traditional programming languages. Now, one of the issues that we've seen with Solidity and with EVM languages generally is that they don't do as much as many of us would like to try to prevent bugs in our programs. In the early days, especially of this ecosystem, when the tooling was relatively young, we'd see DeFi bugs almost every day, and there's no end of headlines I could have put on the right-hand side of this slide. That was a very common thing. The tooling has improved, but it still has not gotten to the point in terms of security tooling, in terms of development environments for reliable and high-assurance code, has not gotten to the point that some other systems outside of the Web3 world have. Now, Solidity was designed to be easy to write, easy to price, and so on. But easy has many dimensions. And in other respects, the EVM was not as strong as some of the alternatives. For example, the EVM is relatively slow as virtual machines go. And as I said before, it has fewer guardrails. It doesn't have the strong type checking and the strong sort of compiler tools and testing and fuzz testing and so on of the same strength that you see with other kinds of programming systems that are more common outside the Web3 world. Now, of course, other projects in Web3 have tried to avoid the EVM entirely, to go with other kinds of systems with some success. But Ethereum already has this really vibrant ecosystem. It already has a large developer base, users, and so on. And the EVM brings things to the table, such as reliable and safe gas pricing and resource management that don't come built in with other languages. And those network effects and the Web3 specificity of EVM and Solidity are not going to go away. So again, to EVM or not to EVM. If you're launching an app, if you're launching an app chain, until today, you had to choose. But why not do both? Why not do them both on the same chain? Why not make them interoperate perfectly? It's time to give Ethereum developers superpowers. So you can use EVM, you can use non-EVM, you can use it on the same chain. Everything fits together and interoperates, and you get the benefit of standard tools without giving up the EVM. That's what Arbitrum Stylus does. It's the next generation programming environment for Arbitrum chains, available only on Arbitrum because of the design, the research, and the engineering from our team. It lets you write smart contracts in Rust, C, C++, as well as some smaller languages like Zig, and it's fully EVM interoperable. To give you an example of what that looks like as a programmer, over here on the right, I have a little piece of Rust code, and this computes the catch-hack hash of a byte string. And it does it by calling one of the standard libraries in Rust, because, of course, existing crates and libraries are supported. Now, all you have to do to make this thing get compiled and to run on Arbitrum is put that decorator, the hash Arbitrum, on the top. Then you use the standard Rust compiler, and thanks to the magic of the Arbitrum SDK, what you will get is a smart contract that you can deploy and run directly on an Arbitrum chain. And again, this works today on Arbitrum 1. Now, one of the big advantages of this is that it offers a lot more performance. So just to give one example, in the time and with the gas that it takes EVM to do 7 simple add instructions, you can compute 1 round of a simple hash function like SIP hash. With Stylus, gas is no longer measured in units of single gas, it's measured in milligas. That's part of the power, is you have the ability to do so much more with the same, on the same chain. Now, one of the reasons this is possible is that the Arbitrum technology proves computation over WASM, WebAssembly. Arbitrum's state already gets settled to Ethereum using fraud proofs. Arbitrum has had fraud proofs since day one, since it first deployed in 2021. And because those fraud proofs are present, and because Arbitrum proves fraud over WASM already, to implement Stylus, what our team had to do is simply extend that capability so that the fraud proofs could be used to prove correct execution of user-submitted WebAssembly WASM code in addition to the WASM code of the system itself. And WASM, of course, is designed as a way to take code from different sources and run it together safely. It was designed and built for the purpose of doing that in a web browser, but the security requirements are very similar in our case. Just to give an example of sort of the power of WASM WebAssembly as a format and as a design, here's a quote from a founder of Docker, saying, if WASM had existed back when we built Docker, we wouldn't have had to build Docker, because it would have solved the problem of how to bring together disparate code, run it together safely, and run it in an environment that doesn't fully trust it, and with performance. That's what WASM does, and Stylus brings that onto an EVM blockchain. So welcome to the multi-VM. That means one chain, multiple programming languages, multiple virtual machines. And critically, this is fully composable. And that means that if you want to call Rust, a Rust contract from an EVM contract, or an EVM contract from a Rust contract, or a Zig contract from a C contract, all of that will just work. It works right out of the box. This is not a new L2, it's not a new chain, it's an upgrade to the Arbitrum technology. So it's been deployed as an upgrade to Arbitrum 1 and Arbitrum Nova, and Arbitrum Orbit chains, the app chain system, ecosystem of Arbitrum, all of those chains as well have this upgrade available. How is this built? Well, the engineering, if you go inside the engineering, what the team has done is taken an implementation of the Ethereum virtual machine, the EVM implementation that has been used on Arbitrum all along, and take a state-of-the-art WASM virtual machine from the WASMer package. It's an open source package which has contributions from a bunch of the biggest Web 2 companies and is used in browsers. Take those two VMs and integrate them together so that each piece of code, each contract, can be dispatched for execution to its VM, whether that's EVM or WASM. But underneath, there's a single state, there's a single update function, state transition function for the chain, and everything lives in one database. That's how you get the compatibility. There's really nothing quite like this anywhere in the Web 3 world that we know of, where you're able to run natively on different EVM or non-EVM virtual machines in a single unified environment with full composability. So this unlocks a whole bunch of things. One of the things that it unlocks is much faster performance. So why do WASM programs run faster than EVM programs? It's basically for two reasons. One is, or three reasons. One is that the EVM as a format for expressing programs is less efficient than WASM. WASM was designed by a very large team very carefully and went through a lot of performance profiling during its design. Second, because the WASM virtual machines have so many more users, there's so much more engineering effort put into making them secure and bulletproof and fast. And that's part of where the large developer base of these WASM systems comes into play. And then third, if you're using Stylus, if you're writing, let's say, a Rust program, you get to use the Rust compiler, which is a more mature, more performant compiler than the Web3 compilers you might be used to in EVM land. So at every layer of that stack, the WASM path is faster, and those factors multiply, compound together to give a big performance improvement from using Stylus. So to give one example, for that Keccak hashing example before, if you were to compare the WASM code I showed you before, running on the same chain, with the same functionality implemented in Solidity, the WASM code is 73x faster. And that means you can do 73 times as much work, or if you do the work once, you'll pay 1/73 as much gas. Now, of course, that is, I chose that example because it shows off the benefit of Stylus. Your mileage will vary based on your workload. But the point is that computation, pure computation, is much faster on Stylus, at least an order of magnitude if you're doing a really compute-intensive task. Also, because of the way that the WASM VM manages its memory, the memory that you use inside a transaction is also much cheaper, 100 to 500x cheaper in Stylus. And that means you can do RAM-intensive computations as well, much more cheaply. And it's not just that these things are cheaper. Some of the things that you would like to do are not possible today on the EVM because they go beyond the gas limit, or because you can do them, but the gas is just too expensive. So this unlocks a whole set of new use cases. One great example here is advanced cryptography, applications that take advantage of things like secure multi-party computation. A good example here is Renegade Finance, which may well be the first dApp to be developed and deployed completely on Stylus. This is a DeFi application which takes advantage of MPC type of multi-party computation type of functionality in order to provide better privacy for users and their trading activity. That's only possible because of Stylus. This application was not able to deploy until Stylus came along. Another good example is evaluation of modest size AI or machine learning models on-chain. That becomes possible with the RAM you have available and with the compute you have available. This is really useful for things like prototyping, doing prototyping research to prototype new L1 or L2 features. You want to have a feature that might be implemented in a precompile. You don't need to launch your own chain. You don't need to modify the core code of the chain. You can deploy this as a Stylus contract and take advantage of the big speed improvement that comes from running in a WASM VM. Anything with heavy computation. You can also use dev tools that you're comfortable with. You're not using a weird domain-specific language. You're not using something that's kind of sort of like Rust or C or C++. You're not using some modified compiler. When you write a Stylus program, let's say in Rust, you're using the standard Rust compiler, and you get all of the benefits of doing that. And that means that if you're doing things like writing and running tests, you're fuzz testing, you're doing static property checking on your code, all the tools that know how to work with Rust code should work on your code. And so you have the advantage of that huge set of tooling that exists in these for Rust or for C, C++, whatever language you're using. So you can write this in a pure way. And Stylus makes available to you as a programmer a straightforward system call-like API that you can call to do the things that are specific to EVM, like like checking account balances or making a payment or calling some other contract. Most importantly here is EVM compatibility. Stylus programs are fully EVM interoperable. As I said before, a Stylus program, a Rust program can call EVM, EVM can call Rust. The user doesn't have to change anything. The user can use their existing wallet to interact with the contract without worrying about what language it was written in or how it was deployed. So that means that you get full interoperation. You can even, if you use the standard proxy upgrade pattern to make your app upgradable, you can even upgrade one part of your app from EVM to Rust to Stylus without breaking anything. There's support for all of this, such as migration, in the Stylus SDK. Here's an example. Here's a Solidity contract, which is calling some other contract. You just write this in a straightforward way. You don't need to worry about whether that's a WASM contract, whether that's an EVM contract. It just works. Stylus is one of those. My experience in programming with Stylus is it's one of those tools where things just always seem to work as you hope. That's a very rare thing. So this is the multi-VM. EVM compatibility is the floor in Web3 development, not the ceiling. And it launched on Arbitrum 1 today. Now I have a couple minutes left, and I want to dig down a little bit more into kind of the nuts and bolts of how this works and what the programming experience is like. First, there are SDKs available with first-class support for Rust and C. So you see here over on the right, for example, you see a piece of code that you write. This is a Rust program, but you can write this data structure definition in Solidity format and declare it like this, wrap it in a macro. And what happens here is that this generates automatically a Rust data structure that you can access natively and naturally in Rust, but it's put into the storage of the blockchain in the format that Solidity would use. And so you get the ability to take this same data and access it in the same way and in the same formats. And this is really useful for a bunch of reasons. It means that, for example, that a lot of tooling will work more naturally if you do this. Standard tooling for, say, inspecting the state of contract storage will work out of the box if you use tricks like this. The SDK is very nice. It provides a lot of these same functionalities. There's a bunch of examples that come with Stylus. For example, there's an ERC20 token example available, which you can use, or which you can use as a sort of example of how to do it. There is direct support in the SDK for implementing the Ethereum ABI. That is the data format that is used when calling a contract. All of that formatting and unformatting and deformatting of data that is needed to call contracts back and forth, that's also happened, also works automatically. It's auto-generated by the SDK. So you really can, in Rust, call a Rust function, which will automatically, thanks to the help from the SDK, cause a cross-contract call to some Solidity code. What about other programming languages? You want to add a new programming language support to Stylus? That's pretty easy. One of our developers one day decided that he wanted to add support for Zig, his favorite emerging systems programming language, and it took him a part of a day, and he ended up adding 16 lines of code to the repo to do this. So adding new programming languages, bringing them in, is really easy. Almost any language which doesn't have a large runtime and which can compile to WASM, which really in practice means can compile at all, you can use with Stylus. You need something low level. You don't want to go with all the formatting and unformatting because you want to do something tricky like, say, compressing your call data. That's available too. There's a very simple bytes in, bytes out interface you can use if you want. If you don't want the automatic compatibility stuff because you don't want to pay for that, that's also available. We've had a lot of feedback on this. As Stylus has been on testnet, There were over 1,000 contracts deployed on the main testnet, and of course, it's now live on mainnet. So people not on our team, people on our team have had experiences, have built interesting and exciting things, but of course, the sky's the limit, because Stylus unlocks developer productivity in a way that hasn't been possible on Web3 before. If you want to know more, here's the URL. It's live now. You can build, you can deploy on mainnet, on testnet. If you have an Arbitrum app chain, you can deploy Stylus there today. So I'd urge you all, invite you all, to use Stylus, do more with Stylus. Thank you.